Assalamualaikum warahmatullahi wabarakatuh. My name is Mustaqim from group A21. This group consists 3 members. Abdul Azim bin Muhamad Fauzi, Mustaqim bin Rosli, which is me, Aiman Fikrie bin Shafie, and this week the lab is power factor correction. So what is power factor? So the power factor is the cosine of angle between voltage and current that is cos theta. It is the ratio between the real power and the apparent power drawn by an electrical load. Mathematically, it can be represented as PF equal to cos theta equal to active power per over apparent power equal to P over S and equal to Watt over VA. This figure is show the triangle power factor. Next. Okay, so basically what we do in this activity, first we need to do connection for this power factor connection. So the connection should be follow this diagram, and so for the next part we need to record the value for IL, for the PF that we get from the activity, and we must calculate for the P, required VAR, QC, required step, and expected EF. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Azim bin Muhammad Fauzi and my metric card number is DE190145. So today I will explain for the connection for activity 1 in lab Mske, which is the power factor correction. So this is the setup for this activity, which is the first one is the power factor correction panel layout, and this one is the resistive loading unit, this one is the inductive loading unit, and the last one is the capacitive loading unit. So for this exercise we need to conduct two activity, which is the first one is by without using the capacitive loading unit, and the second one is by using this capacitive loading unit. So I will explain the component in the power factor correction panel layout here. So as we know that this is the switch, and then this one is the current transformer, this is the main circuit breaker, and this is the measurement unit. So it can measure anything, but in this case we need to measure the power factor. This one is in digital, and then this is also the measurement unit, but this one is analog, also to measure the power factor. And then I will explain the connection for the power factor correction. So as we know that this one is the three-phase connection, so there will be three line, which is the red, yellow, and blue. So it came from the main here and then go to the switch, and then from here it goes to the main circuit breaker, and then the output here will go straight to the load here. And then before I forgot, this panel layout are used to measure the PF, which is the power factor. As we know, the power factor means that the cosine angle between the voltage and current, so we have to measure the voltage and current. So as we know that to measure the voltage we have to place the measurement unit in parallel for the voltage, and for the current we have to place the measurement unit in series. So we will have to measure the voltage and current first. So for the voltage we have to pick any two phase. So for this digital one we pick yellow and blue phase. We have to connect in parallel. And then for this analog we pick red and yellow phase, and we connect in parallel. And then for the current we have to connect in series, so we take the current from the current transformer. As we know that CT or current transformer are used to lower the current, and then we take the current from the CT and then connect it to the measurement unit digital, and then the output will go straight to the analog, and then the output analog will go straight to the negative side of the current transformer, and then go straight to the load, which is the resistive loading unit, inductive loading unit. Between these two we have to connect in star connection. As we can see here, this red is connected in parallel between these two loading unit, and same goes to the yellow and blue. For the neutral, there will be a looping from phase to phase. This is for activity 1, and then for the next activity, we just have to place the capacitive loading unit here and also install connection between these three loading unit. So for the capacitive loading unit, we place the capacitive loading unit used to complete the power factor correction, which is the PFC. As we know, PFC are used to improve the power factor of the circuit and also to reduce the power loss and improve the efficiency. So by adding this capacitive loading unit, we can simply reach the objective for this activity. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Aiman Fikrie Shafie. My machine number is BE40301. So I will continue my part on presenting the expectation on power factor after we adding the capacitor. Okay, in order to know the expectation of the power factor, we need to do several steps to know the value of the capacitor. So the first step what we need to do, we need to find the power for each step here, and then we need to find the required VAR. So after we found the value of the required VAR, we need to refer to this table here, which is our system is VAR 3-phase Y connected or star connection, and then for example this step L greater than R, which is 1 greater than 1. Our required VAR or QC that we calculated is 622.770. Therefore, we can compare it to the nearest value to the 600. Therefore, from this table, it can be used the 714.2 because it is approximate 602 approximate to 714.2. Therefore, when we choose here, we can obtain the value of capacitor that we need to add to the system in order to improve power factor, which is 13.2 microfarad, and this is all the AC and operating current. So therefore, the step is 1, and the expected power factor should be greater or equal than 0.5, because the previous on the system, our power factor is 0.5. We need to improve it to 0.95. So after we done the steps, we expect the power factor should be greater or equal than 0.5. Okay, last part, which is the conclusion. After done with this lab, what we can obtain, which is the importance of the power factor correction, is the first point is we can reduce the electrical bill. This is because when we improve the power factor will eliminate the reactive energy. When there is excessive reactive energy, the system or bill will get penalties, which is we need to pay higher. We need to pay. It become more expensive to pay. Right, when power factor eliminate negative energy, so and also it can reduce power losses, therefore our electrical bill can be reduced. So the second point is voltage drop can be reduced. So for this part, when we install the capacitor at the power factor correction, it will reduce the overloading and harmony of the system. And then last but not least, it can improve power factor, which is the biggest point. When power factor is improved, the instability of the system or the instability of the component can be reduced. In other words, there will be no failure. It will reduce the failure and the system will be stable. I think that's all for my part. Thank you.